Okay. As I told you, let us not wait. Start the session. Otherwise, not able to complete. Okay, fine. In this topic, we are going to discuss about hazard identification techniques, and also we'll see some of the investigation techniques as well. If you see in a hazard, first of all, we should understand what exactly the hazard means. The hazard is an inherent property of a substance or a safe or unsafe condition or unsafe action or situation to harm or to cause a harm which may cause human injury, damage to property or environment, or some of the combination of this criteria. So even now it is having an inherent property of an substance or unsafe condition, unsafe action or situation to cause harm to the human injury, damage to property or environment, sometimes combination of these. A chemical hazard is a hazard due to the chemical including storage, process, handling, and also it is realized by the fire, explosion, toxicity, and radiation. The hazards may be during handling, during storage, during process of handling, storage, and also preserving, and it will be resulting in fire accident, explosion, toxicity, or radiation. And risk is the likelihood, chance, frequency, or probability of an undesired event. Risk means it is a likelihood, a chance, or frequency, or probability of an undesired event occurring with a specified period or under specified circumstance and its severity. Simply, we can say risk equal to probability into severity. That is about hazard and risk. If you see the detection techniques, we'll see some of the detection techniques. A visible hazard can be detected by various techniques, which means the hazard is able to see. So it is by the human eye we can able to identify the hazard. There is a visible hazard. How we can identify? Planned inspection based on the statutory requirement or based on the checklist, based on the safety survey or safety audit or safety sampling. And also detection and monitoring systems, functional test or machinery and equipment, accident investigation, repair shop, store consumption, and also shop feedback. These are the various techniques we can use for the identification of a visible hazard. అంటే కంటికి కనపడే ప్రమాదాలన్నింటినీ ఈ టెక్నిక్స్ ద్వారా మనం కనిపెట్టవచ్చు. Example of visible hazards are unguarded machinery, bad housekeeping, wrong practices. To discover such hazards, careful planning, inspection system is necessary. You can see some of the steps in this inspection machinery. Make a list of statutory applicable provisions of the Factory Act and make a survey on the plan to compare the existing provisions and also find out the missing provisions. And we have to make a list of the legal requirements and provisions. Then we have to see that which and all is miss or which and all we need to fulfill. and make a list of materials, processes, operations, vessels, equipment, machinery, and classify them as hazardous and non-hazardous. And chemical should be classified according to their hazardous properties. One list we will make for all the requirements. One list we will make for the equipments and materials. And prepare a layout of the plant, machinery, equipment, premises, and also equipment services like power, water, and air and gas. So by this segregation of the process, we can be able to identify the hazards very easily. Then next, invisible hazards. How you are going to identify a invisible? అంటే మనము కంటితో చూడలేని ప్రమాదాలు. The invisible hazard like a gas leak, concentration of toxic and hazardous vapor, malfunction or also failure of a machinery, equipment, pressure plants, and miscellaneous environmental factors may cause a sudden accident and also a heavy damage. Because this is not visible, it is invisible. It will make a huge damage, and they must be detected and controlled by a built-in self-corrective systems, and the devices used are detectors, recorders, alarms, chips, probes, and also sensors, limit switches and meters, electronic or auto controls, scrubbers or incinerators. These are the devices we can use to identify all this invisible hazards. In motor missions, various automatic movements takes place near and around the point of the operation. A feed devices, clamping action, workhead movements should be interlocked with each other, and each position of these elements must be sensed and also linked with the command control, like CNC missions. The CNC mission operational spindle will be interlocked with the main doors. So if you are, until unless you are not closing the door of the machine, the spindle will not start the movement. A repair shop data reveals a clue to the unsafe conditions like poor design, defective materials, and also poor construction. Repair shop in the sense the equipments or any particular mission is keep on getting repairs. In the sense the design of the equipment or the material which they've used for the making of that equipment, which is not a proper, which is not a good material, and wear and tear. A repetitive repair indicates a major hazards, and similar store consumption data also indicates some defects. They should be a regular feedback information from repair shop, stores, operations, foreman to monitor hazards and to take corrective actions. Store also. For example, I'll take a pipeline. They keep on the gaskets consumption is more from the store. In the sense, whatever the gasket they are using in that particular pipeline, which is not meeting the requirement. That's why they are changing many times because of failure. Then risk analysis and also assessment method. How you are going to do a risk analysis and assessment. The procedure for this risk assessment is stated below, which is includes a risk analysis and assessment. If you see the steps for this, it is in a qualitative analysis. How we can do a risk, look for the hazards, and decide who might be harmed and how, evaluate the risk, and decide whether the existing precautions are adequate or whether more should be done, and record your findings and review your assessment and revise if it is necessary. So these are the steps in the risk analysis. Look for hazards, then decide who is going to be harmed and how they are going to get into that. Then evaluate the risk and decide whether the existing precautions are adequate, if it is required any more. Record the findings and review the assessment. And it is a qualitative only, no factor is quantified, effect of controls measures to be taken into account. Qualitative in the sense, it is a completely theoretical. For example, we can say the risk is more or low, high, medium. If it is in a quantitative, they can say that the risk number is 6, the risk number is 9, the risk number is 20, the risk number is 24 by the quantification. It is in a qualitative analysis. Then 5 steps for the defining the risk assessment. Here what will happen? Identification of sources of the hazards and their causes, and it is a qualitative example hazard. And this step is known as hazard identification, an analysis of mechanism of the hazardous occurrence and terminal consequences of hazard. And this is a quantitative, which means a hazard consequences analysis quantifies the concentration of the deaths and also injuries and damages and damage distance and also effective. This step is known as hazard analysis. So in other method, what we are doing in qualitative analysis will be example of an hazard. But in this particular risk assessment, what we do is we will analyze the mechanism of hazard occurrence. అంటే ప్రమాదాలు అనేవి ఎలా వస్తున్నాయి, how the hazard is created, and also a terminal consequences of hazard. అంటే దాని యొక్క కాన్సిక్వెన్స్ ఏంటి. Here we are going to quantify the consequences. ఎంతమంది చనిపోతున్నారు, ఎంత ఇంజరీలు అవుతున్నాయి, ఎన్ని డ్యామేజ్ అవుతుంది అంటే the value of the damage. And here the probability, frequency or likelihood of the hazard occurring, and also then this estimation of the risk, and this is also a quantitative. It is a depth of failure rates, number of chances and cycles, and also reliability engineering. This step is known as the risk analysis. So here they are going to quantify the failure rates, how many times it is going to fail, and number of chances, in number of how many cycles it is going to fail, and all they will analysis here. Then the judgment of acceptability of risk against the legal and also social political criteria will be taken care. Therefore, it is usually a quantitative analysis. If you see the risk assessment, as of now we have seen the risk analysis. If you see an assessment, a decision making and also taking control measures to prevent, reduce, transfer also risk. And this is a mixture of a qualitative and also a quantitative criteria. And also the steps is known as the risk management. The risk or safety, a manager should assist the top management in this regards. If you see here a measured value of the hazard and also calculated risk is compared with the possible safe limits. So how you are calculating? Once you have done your analysis, we will compare with the existing standards. For example, there is a high noise. So we will do an analysis. We will identify that, okay, this is the noise level which is happening. Then we will compare with the possible or permissible safe limits, whether it is meeting the requirement or not. Now we'll see some of the types or methods of this risk assessment. A simple or quantitative risk analysis is identification of hazards and also taking appropriate control measures. Simple or qualitative risk analysis. It is as per the 5-step explain already we have seen. And here the quantification of hazards and their terminal consequences, which means damage. Terminal consequences means whatever the occurrence or whatever the impact of those hazards, and severity of injury or loss are not worked out, and it is sufficient to think about the adequacy of existing measures, and vice versa, the hazard identified and also adapt more safety measures if necessary. And it is important aspect, it is to consider the effect of control measures provided in place and know think the residual risk and also residual control measures. So here what will happen, they are not going to do any quantitative assessment. Here they will check only the existing controls are sufficient or not. And also they will see the, it is important aspect to consider the effects of control measures providing in place and to think of residual risk. So once you have put this existing controls, still is there any residual risk is there or not, which means still there is a risk after putting the control measures as well. That also they will see here. And if you see in a quantitative assessment, the hazard potential is quantified and possible risk also determined in the failure rate data available, and then it is compared with the permissible standards. Here they will see the quantification. What will be the chances of failure? In how many cycles it will get failure? If it is gets failure, what will be the damage? Then they will compare with the permissible standards. And this will indicate whether the calculated risk is lower than or higher than the permissible limit, Based on this, a new control measures or modifications in existing control measures can be decided. Based on the quantification assessment or quantitative assessment only, they will understand the adequacy, అంటే ఉన్న కంట్రోల్స్ అనేవి మనకి ప్రాపర్గా సరిపోతుందా లేదా. స్టిల్ ఇఫ్ యూ వాంట్ టు టేక్ ఎనీ ఎక్స్ట్రా కంట్రోల్స్, the values followed hazard potential can be quantified: properties of the material, storage parameters, process parameters. అంటే మెటీరియల్ యొక్క ప్రాపర్టీస్ అదేంటి, సాలిడా, లిక్విడా, కరోజివా, పాయిజనసా, ఎక్స్ప్లోసివా, ఆక్సిడైజింగ్ మెటీరియల్, మిస్లేనియసా. దెన్ స్టోరేజ్ పారామీటర్స్ అంటే ఏ కండిషన్లో స్టోరేజ్, కంపాటబిలిటీ చెక్ చేయాలి, అట్ వాట్ టెంపరేచర్ ఇట్ కెన్ బి స్టోర్డ్ అండ్ కోల్డ్ కండిషన్స్ ఎక్సెట్రా. అండ్ ప్రాసెస్ పారామీటర్స్ ఏవైతే ప్రాసెస్లో ఇన్వాల్వ్ అవుతుందో అందులో ఎటువంటి పారామీటర్స్ అనేవి ఫాలో అవ్వాలన్నీ కూడా ఇక్కడ అసెస్ చేస్తారు. అండ్ ఆల్సో మాన్యువల్ ఎక్స్పోజర్స్, visible or measured hazards, and transportation hazards, pollution hazards. All these things will be covered in the quantitative assessment. And this value gives the severity part of the risk. If you see a simply value of the control measures provided can be quantified, depend on the poor controls to be a best control. And proper classification of good, better, and also best controls is necessary. These values give a probability and also part of the risk. So whatever the controls are there, it should be properly defined, whether it is a good control or best or a better control. By using the formula risk is equal to severity into probability, the existing risk level can be calculated by identified low, high, or higher or highest risk. Generally, we used to do this risk matrix 3 by 3 or 5 by 5 matrix. Based on that, we can able to understand the quantification of that risk. Based on that, we can take proper measures. And this method is used to carry out a material wise risk assessment, and this method and also other methods using a ranking matrix or used to carry out the activity wise risk assessment. So that's why we do a risk assessment for the all the activities, so that we can understand which activity will be under higher risk and where we have to take a control measures. There are two methods. The methods based on the formula risk is equal to probability and severity. This method is mostly useful for the assessing risk to the workers in a factory and hazards considered material wise or activity wise or sub activity wise. Here what they're doing, if I have to listen carefully, the hazards are considered material wise or activity wise or sub activity wise. In the sense, we have to consider all the areas. And the method or computer model, this method is mostly useful for the assessing the risk to the public in vicinity, like gas dispersion models are used, and also toxic concentration and the heat radiation or explosion, overpressure, and effect at the different distances, damage distances are calculated. Other one is gas dispersion model. For example, in case of any failure of the gas, in case of any leakage, how far it is going to spread. In case of any explosion happens, how far it is going to affect the people. Another is risk control measures or elements of the risk management. Then how you are going to control the risk. We have seen hazard identification techniques, risk analysis, also qualitative analysis and quantitative assessment. Now we'll see how this risk can be controlled. One is the mission identification. In the sense, first of all, we have to establish a risk management policies and procedures. Then risk communications, whatever the first to create a policy and procedure for doing this risk controls. Then risk communications, we have to communicate the whatever the risks are there. Then management of the contract and also portfolios, we have to define the management of the contracts. Then claims supervisions and reviewing, monitoring, and evaluating the risk management program. Whatever the programs or initiations you have conducted, it has to be reviewed. Then risk and uncertainty assessment. How we'll do risk and assessment? Hazard identification, risk analysis, risk measurement, and also risk assessment. Then other control measure is risk control. How we will control? Risk avoidance, risk or low prevention, or low reduction, information management, and also risk transfer. Risk transfer in the sense you are transferring it, you are contracting it. For example, in case of any activity which is done by the company employees, it can be contracted, subcontracted. So the risk level will be transferred. And risk financing, risk retention, and also risk transfer, and program administration, day-to-day short-term planning, and also long-term plannings. These are the some of the control measures of the risk. Now we'll see risk management activities. How you are going to manage the risk which you have identified. If you see some of the steps in this, identify the hazard and analyze the risk, select the and evaluate the remedies, implement any necessary safeguards. What we have to do? First, we have to identify the hazard, then we have to analyze the risk, then select the remedies, which means corrective or preventive action. Then we have to implement that. Audit and review if necessary. Once you have done this, the risk control also includes methods to improve understanding, awareness within our organization of the activities and also affecting exposure to the risk. And here we have to do a review as well. Then risk reduction activities can be focused on altering and modification of the hazard. So here what is happening? You are trying to reduce the risk. You are altering and modification. So you are changing or you are reducing it. Altering modification of environment in which the hazard is exist, and intervening the precautions whereby the hazard and also environment interacts. Example, wall within the structure of the separate fire prone area from the other areas. So we are building a wall to segregate the two different areas. Now we'll see some of the duties of the risk managers. Nothing but a safety officer. What it will be his duties. One is assisting organization in identifying the risk. First of all, we have to advise or assist the organization in the identification of all the risk in this factories. Then implementing risk control programs, as we see. Then reviewing contracts and also documents, example, safety audit, emergency plan, safety reports, etc., including insurance for risk management purposes, and providing education result training on safety matters. We have to give proper training education on all the activities, implementing statutory provisions, and arranging non-insurance financing schemes and self-insurance and also capitative insurances, and claim and also legislation management. Whatever the claims which is happens in case of any failure happens, that has to be addressed, designing and also coordinating employees benefits and programs. It's also one of the duty. The employee benefits programs must be designed and also coordinated. Then there is one more technique, PHA. I think somebody asked, preliminary hazard analysis. This is an initial study to determine the hazard and causes, effects and controls, facts of the proposed product or a process or operations are to be known to determine the hazards. For example, a product using electric power, the hazards to be pre-assumed are electric shock, burns, fire, sparking, hot surfaces, inadvertent start of the equipment, failure of the equipment to operate at critical time to cause an accident, radiation effects, electrical explosions, etc. So what will happen? It will identify the what kind of hazards can be expected from that a specific product or in a process. Similarly, the adverse effects of foreseeable hazard causes like the chemical exposures, reactions, accelerations, mechanical effects, the pressure, etc. will be there. Since the pH is the fast and also cost effective and not complicated like the methods of hazard assessment, and it should be adopted as a first step. It's a of any hazard analysis. If you see the steps in this, assume a type of accident or hazard possible, example fire or explosion or toxic release, and find out which of the plant components, systems or missions can cause this incident. Here we are assuming that okay, one fire accident have been happened, then how the fire accident has been happened, which are the situations or components which is causing to have a fire accident. Then find out the events, which means results initiating that hazard or accident, which means releasing of explosive or toxic gases, runaway reactions, leakage, or running without a guard. First, we'll take the type of hazard possibility. Then we will find out the causes to create that hazard. Then we will find out the initiating events to create that hazard. And this will naturally suggest the corresponding safety device like cards. And the component system part should be can be further explained and also examined, analyzed for the details of failure and how it can be removed. And if you see this preliminary hazard identification is required at different stages of the projects. It can be used in the stage of R&D or pre-design stage, a design stage, and the commissioning stage and operation stage also it can be used. This PHE is generally used for the early identification of hazards based on raw material, intermediates, final products, plant equipment, interface among these components, operating equipment, operations, and other facilities, and also safety equipment which are required. Can be used for early identification of hazards in the each activity. And other one is a failure mode effect analysis. I think most of the people are familiar with this FMEA, failure mode effect analysis. This failure mode effect analysis, which is not going to discuss any causes which is errors of any humans. It is going to talk about the failure of an equipment. This procedure considers each component of the plant in turn, and also possible failure modes and the rates and their consequences. The results are recorded in a standard form. Hazard study is a well developed form of a FMEA, which means from the FMEA it has been evolved as a hazard, which means designed properly. It is a process of hazard identification where all known failure modes of the components or features of a system are considered in turn of undesired outcomes. In this, what will happen? It is a tabulation of system or plant equipment failure modes. Here it is talking about only how an equipment can fail. Each failure mode assigns a critical ranking. Human errors, operational errors is not generally examined in FMEA. This point we have to remember carefully. Human errors, operational error is not generally examined in FMEA. And this method is derived from reliability engineering. A product or piece of complex equipment is divided into components, and each component is studied to know how it can fail. So if you take in a car, they will study the complete parts of the car, how a specific part can failure. Then failure rates of each item are determined and also listed. The method is used to determine a satisfactory operational life of an equipment. For example, now they are giving 1 lakh kilometer for an engine. They will test the engine for 1 lakh kilometers, whether it is properly maintaining or it is properly running or not. And it is also studies about the how a failure might occur, modes and frequencies of failure, and also necessity for proper and also timely maintenance and replacements. Why we do FMEA? It will be done for proper maintenance and also replacements of the parts which is used. That's why all the automobile companies they will do this FMEA for their manufactured goods. So that's why they are confident that up to 1 lakh kilometer they will give a guarantee because they would have done all the tests within that range. And this knowledge can be used to improve the life and also quality of the product. Thus, the preliminary or more useful to manufacture of and then users. Is more useful for the manufacturer because he can claim all the benefits. He can say within 1 lakh, I will give everything. And FMEA has its own limitations, data of failure rates, and also calculations for failure frequency must be correct. And a method cannot analyze the problems created by a bad design, adverse environment, and also operational errors. It talks about only the component failure. If it is data, it is wrong, then your calculation will go wrong, and your the frequency of failure rates it is wrong, then the calculation will be go wrong. The method cannot analyze the problem created by the bad design. In case of any design failures is there, it is not going to identify, and also adverse environmental conditions and operational errors. The people which are not operating it properly, those cases also it is not going to analyze. To see an example, the probability of occurrence can be expressed in terms of average time between a failure. If you see in a probable, one failure before 10,000 hours of operation, and reasonably probable one failure during 10,001 to 1 lakh hours of operations. May be remote. It will happen or not happen. One failure during 1 lakh 1 to 10 million hours of operation, and extremely remote, it is not expected. One failure of 10 million hours of operation. These are the probability of occurrence of a repair or a damage. If you see the failure frequency data is difficult to obtain, it is obtained from two types of testing of a component, a performance test and a reliability test. With this test, we can able to understand the probability of the failure. And the failure classification distinguishes between possible effects of assured failure and also apart from the classification and also safe, managerial or critical, catastrophic indicating increases in the severity. Then hazard, I think this is a known technique to everybody. Hazard operability study. It is in a multidisciplinary team, a search deviations from the design intent. Here it is completely talking about the deviations in the design intent. In the sense, whatever the design you want, whether it has been working under that particular specification or in that particular mode. That is your mode of or design intent. Throughout the fixed set of guide words and also checklist and also knowledge, a hazard can be conducted to check the design or operating procedures for a new project or an existing one. It can also be conducted to improve safety of the existing facilities, and it is also useful before implementing a significant modification or for other operational or legal reasons. And after carrying out a preliminary hazard analysis (PHA), as explained earlier, the plant component system and machineries. They will do in the design phase or implementation phase also. They can able to do this hazard analysis. Also, the equipment part which can cause a major hazard becoming known to us now to find out the deviations or malfunctions leading to such event and also its mode of operation. The hazards help us to complementary to a PHE because this PHE is going to be developed in a hazard. It is in a complementary of PHA, preliminary hazard analysis. And this hazard study is carried out to determine the deviations from normal operations and also operational malfunctions and which could lead to uncontrolled events. So what we'll do, we use it to identify the deviations from the normal operations. What kind of deviation can be happen from the normal activity. Although the hazard study was developed to supplement experience-based practices when a new design or technology is involved, and its use has expanded to almost all the phases of the plant's life, and it is based on a principle that the several experts with their different backgrounds. That's why it is a multidisciplinary function. So it is not about only one guy. There will be a n number of people can be, or all the department people will be involved in this hazard analysis. Therefore, hazard study is preferred by the multidisciplinary expert group, always including workers familiar with the installations. Even we can involve workers also in the installations where they are familiar with. And the examination procedure takes a full description of the process, systematically questions every part of it is discover and how the deviations of intention of the design can occur, and also decides whether these deviations can give rise to a hazard. So whatever the deviations which is happening in the process, whether that specific deviation can leads to hazard or not, it is going to differ. Now we'll see one small step. Each of the design is analyzed with a questions formed around the number of guide words. There are a guide words, 7 guide words for this doing an hazard. Based on the guide words, they will make a questionnaire. These guide words which ensure that the questions are passed to test the integrity of each part of the design will explore every convincible way in which the design could deviate from the design intent. Also, each deviation is considered for that the consequences is could be lead to. And also, a potential hazards are noted for a remedial action. Also, trivial for a meaningless, and also consequences are adopted. If you see the steps in this hazard, it is an early stage of developing to decide at the site and also identify the major hazards. When and all we can able to conduct. In the early stage of development, we can use this hazard study to design. At the design freeze stage, when you are going to freeze your complete design of the plant, during that time also, we can able to do this hazard. And at pre-startup stage, before starting up the process, and studies on existing plant, even existing plants also there also we can do, and studies prior to the plant modification. If you are going to do any modification of the plant also, you can able to do this. And studies prior to taking a plant or out of the service, is the some of the plants which are out of service, which means shut down long back, now you are going to reuse it. In that case also can be used. Studies on research facilities, if you are working any research activity or R&D centers, there also you can use this hazard study. Then hazard operability study. A procedure of hazard operability study follows the sequences. What sequence it will follow? First, they will define the objective and scope. Okay, what you are going to do? What is the scope of this study? And select the team.